Bismillahirrahmanirrahim. Assalamu alaikum, my dear students, viewers and spectators. Welcome to Ghulam Hussain Bhatti Chemistry channel. The topic of today's presentation is Avogadros number, chapter number 1, first year chemistry. It's extremely important topic as per paper point of view, as per the chemistry point of view, because it with the help of this topic we can solve many numericals. Numerical problems can be solved with the help of this conceptual topic. Avogadro number, this number was named after an Italian chemist, Amedeo Avogadro. He was a chemist and physicist as well. It is a very large number indeed, and its value is 6.02 10 की power 23. We may write 6.02 10 की power 23 as it is written in the board. Now, my dear students, it is a very huge number. It is denoted by NA. N for number, A for Amedeo Avogadro. Now, my dear students, what is Avogadro's number? Dear students, 6.02 10 की power 23 is such a large number that if all the people in the world started counting at a rate of 1 per second for the rest of their lifetime, in total all the numbers counted still not be larger enough as compared to 6.02 10 की power 23. This means that Avogadro number or Avogadro constant, its value is 6.02 10 की power 23, is a number of atoms, of carbon in exactly 12 gram of carbon 12. Thus we can define Avogadro number. The number of atoms of carbon is exactly 12 gram of carbon 12. My dear students, in other words, we can explain that 12 gram of carbon 12 is found to contain 6.02 10 की power 23 atoms. A mole represents the collection of 6.02 10 की power 23 chemical units. And mole and Avogadro number is denoted by Na. N for Avogadro, N for number, A for Avogadro. Students, how large 6.02 10 की power 23 is? It is very important to note over here that how large 6.02 10 की power 23 कितना बड़ा होता है. Now, if you spend, dear students, if you spend 10 lakh rupees per second, if you spend 10 lakh rupees per second, you will need 19 billion years. You will need 19 billion years to spend 6.02 10 की power 23. How many? It means that how many generations could you survive? It means that Avogadro number is a huge number. Avogadro number, what is Avogadro's number? It is the number of particles. Number of particles means that atoms, ions, molecules or formula units present in 1 mole of a substance. Its value is 6.02 10 की power 23 and it is denoted by Na. N for number, A for Amedeo Avogadro. Its full name was Amedeo Avogadro. Now, my dear students, I will explain it with the help of different examples of elements, compounds and ions and their formulas, and one short question as well. Now, in the case of elements, for example, 1 mole of, 12 gram of carbon, it will be equal to 1 mole. And this 1 mole of carbon, its value will be equal to 6.02 10 की power 23 atoms of carbon. So it is a huge number. Now 1.008 gram of hydrogen, it will be equal to 1 mole of hydrogen, and its value will be equal to Avogadros number, that is 6.02 10 to the power 23 atoms of hydrogen. Now in the case of compounds, for example, 18 gram of water is equal to 1 mole of water, and this will be equal to 6.02 10 to the power 23 molecules of water. And similarly, my dear students, 58.5 gram of sodium chloride will be equal to 1 mole of NaCl, and its value will be equal to 6.02 10 to the power 23 molecules of NaCl. Now third and last but not the least is number of ions. For example, dear students, 98 gram of sulfate ion will be equal to 1 mole of sulfate ion, and this will be equal to Avogadros number 6.02 10 to the power 23 ions of sulfate. And similarly, 62 gram of nitrate will be equal to 1 mole of nitrate ion, and this will be equal to Avogadros number 6.02 10 to the power 23 ions of nitrate. Dear students, formulas to calculate number of particles, that is atoms, molecules and ions. Now number of atoms of an element, it will be equal to mass of an element divided by atomic mass multiplied by Avogadros number Na 6.02 10 to the power 23. Now second formula is number of molecules. Number of molecules of a compound is equal to mass of the compound divided by molecular mass multiplied by Avogadros number. Now the third formula, number of ions of an ionic species, it will be equal to mass of the ion divided by ionic mass multiplied by Avogadros number 6.02 10 to the power 23, and by putting the values we can solve any numerical problem. Now my dear students, there will be a short question. What is the short question? 1 mole of different compounds has different masses but same number of particles. My dear students, there will be a short question. 1 mole of different compounds have different masses but same number of particles. Explain. Dear students, you know that an atom of sodium is 23 times heavier as compared to 1 atom of hydrogen. Because sodium has atomic mass 23 while hydrogen has atomic mass 1.008, so it means that sodium is 23 times heavier as compared to 1 atom of hydrogen. In order to have same number of atoms, sodium must be taken 23 times greater in mass than hydrogen. Similarly, my dear students, magnesium is twice heavier as compared to carbon. Magnesium has a mass 23. Magnesium has a mass 24, while in case of carbon has mass, atomic mass 12. So magnesium is twice heavier as compared to that of carbon. Thus 10 gram of magnesium and 5 gram of carbon have same number of atoms. It's very simple that if we take 10 gram of magnesium and 5 gram of carbon, then both will have same number of carbon, because magnesium is twice heavier as compared to that of carbon. So we can conclude here that it is because individual particles of different substances have different masses, because individual particles of different substances have different masses. This is the answer of this important short question. My dear students, there are two formulas with the help of which we can find out the numerical problems and their solutions related to moles and Avogadros number. First relationship is between a relationship between mass and number of particles. Dear students, its formula is number of particles, that is atoms, molecules, formula units are ions. They will be equal to mass of the substance divided by molar mass of the substance multiplied by Avogadros number 6.02 10 की power 23. And similarly, we can find out the relationship between moles and particles. For that relationship, first of all, we will have to calculate the number of moles. Number of moles can be find out with the help of this formula. Dear students, mass of the substance divided by molar mass of the substance. When we find out the number of moles with the help of this formula, then we can find out the relationship between moles and particles with the help of the formula given below. That is, number of particles is equal to the number of moles which we have calculated here, and multiply number of moles with Avogadros number 6.02 10 की power 23. With the help of these two relationships, these two formulas, we can find out any numerical problem. My dear students, this is all about Avogadros number and how we can find out the Avogadros number in the case of element, compound and ion, and their and then what is the relationship between between mass and number of particles, and between number of moles and particles. Dear students, thank you very much for watching my video. Please like, subscribe and share my video with your friends. Thank you.